Hi friends, and welcome to our first lesson of the course, Introduction to Blockchain. So what is a blockchain? Let's take a look. Blockchain is a decentralized, shared, distributed, cryptographically secured, immutable, and hence trusted ledger, which no single user controls and which can be inspected by anyone using the internet. So let's take a deep look at these terms and understand what they actually mean. Let's understand first what a ledger is. Ledger is like a diary or sheet for recording entries or transactions, usually financial type of transactions. For example, Bob gives Alice 0.1 BTC on 1st January and 0.2 BTC to John on 2nd January. So considering Bob is maintaining a ledger, he will write two entries in his ledger with respective details of transactions. So how will our ledger looks like then? Like, we have a name of the user, Alice, then the timestamp, when was the transaction sent, and the amount. And same goes for John. So our ledger will be something like this. Okay. Moving towards decentralization. Decentralization means removing control of any single centralized authority. It means our ledger is not controlled by a central authority or any user. Sounds good, but how it's done? All the transactions or records that are created in our ledger or blockchain are validated by a network of computers of blockchain called nodes. We will get to it later. So there is no single entity that verifies transactions. It is controlled and validated by a network of computers of blockchain. This is the main advantage of using blockchain technology. Assume that no authority have control over the system and your data. Your privacy is secure and the system will work as it is designed to work. Distributed. So what's a distributed ledger? Transactions performed are not stored on any single server or any single entity. They are distributed across multiple computer systems called nodes. Each node contains a copy of every transaction that has ever occurred on blockchain. Every copy of data on each node is updated regularly whenever a transaction occurs on network. This process minimizes intrusion of any hacker to nearly zero, because hacker will have to change the transaction records in every copy of ledger that is replicated or shared on different computer systems on blockchain networks. In simple words, that is shared on our nodes. So let's take a look at this example. Consider these 4 points as nodes. Every node is connected with each other and maintains a copy of ledger. Connected with each other, and every node is maintaining a copy of ledger. This ledger is up to date, and whenever a transaction happens, these nodes will be informed with new transaction record. All nodes then validate the transaction, that it's okay or not. If it is validated, then it will be added to the ledger of each node. So this is the example of a distributed system. What is cryptographically secured? The data stored in blockchain is secured with cryptographic hashes. Hashes are codes that are generated by performing some cryptographic algorithms. Hash algorithm turns large amount of data into a fixed length of hash string. Same hash code will be generated every time for same data from same hash function. If we are using same hash algorithm, so the resulting output will be of same length and same characters. And if the data is modified, the hash generated will be entirely different from the old hash. Other point to be noted is no two values can generate same hash value. It means two different inputs will always contain two different outputs. Every value has a unique hash value. The Bitcoin blockchain uses SHA-256 hashing algorithm. SHA-256 is a commonly known and very popular cryptographic function, and it is a very strong cryptographic function that transforms given input value in a secure 256 bits long value. And it's not easy to crack SHA-256 value because it will take very long time and with a huge computational cost. So here is an example of hashing function. First we give input fox to our hashing function and get this output of 256 bit. Then we increase the length of our input and again we got the same length of output, but it is an entirely different one. In this way, whatever length we give to our hashing function, it will always return same and unique hash code in the output. One more thing to notice is in this line, if we change just a single character and input to our hashing function, the output will be completely different from the data that was previously obtained. So this was the cryptographically hash functions. So what is immutable? The data in blockchain is cryptographically secured. Hence, it cannot be altered. That's the real meaning of immutable, that it cannot be changed or modified. The data or transaction values processed with hash values, so they are not easy to break or change. The data or our blocks that are connected to form a blockchain, they also contains the hash for previous data to couple the chain together and to keep the track of records. Therefore, no intrusion or data alteration can be done easily. So this was the first lesson. See you guys in the next session.